Supplemental math videos from Circle Christian School.
Simplify, distribute, and combine like terms. The first of the Kingdom of Pi steps for solving an algebraic problem is to simplify all the terms. It is step 1, distribute, then combine like terms, but always start with the fence of equality. When we distribute, basically we are multiplying our numbers to numbers and our letters to letters. When we multiply same base to same base, the power is always being added together. When we combine like terms, we're always looking for terms that have the same letter and the same power to it. Those are the ones that we can actually add together, and we're only going to add together our coefficients. So for the first problem here, you notice that we have an x to the power of 2 and an x to the power of 2. So what we're going to do is basically take a negative 2 and add it to a 6, and those are being multiplied to x to the power of 2. It will give us 4x to the power of 2. See, we just add and subtract the coefficient, the number in front. Next one, we have a 9y minus 4y plus 8y. Everybody's a y. So 9 take away 4 is 5, plus 8 more is 13 y's. On the next problem, you'll see that we have some distributing. Distributing is the property of multiplication over addition and subtraction. When we multiply, that is where we multiply number to number and letter to letter. I always use a I call it my rainbow system, where I let my eyes know exactly where the operation's happening. So we have a 5, and we're going to multiply it to x to the power of 2. I have a 5 times a negative 3, gives me a negative 15. I like to do signs first, math second, x. And although there's this little rather invisible 1 here that is actually being distributed to everybody inside because it's a plus sign, nothing's going to change here. So we just end up with a positive x and a positive 2. Then combine any like terms. I always start with the term that has the highest power, and we see that we have an x to the power 2 as the highest. I like looking from left to right. So we have a 5, x to the power 2. Next, I see that we have x's, x's to the power of 1. So I'm going to add the coefficients. It is okay to actually put a 1 in front of any variable. Just kind of helps give you a little bit of place value here, and you don't lose that the x actually has one value here. So negative 15 plus a 1 is a negative 14, and the term stays the same, plus a 2. And we end up with one of those cute quadratic equations that you remember from Algebra 1 that gave you those little parabola guys. Any x to the power 2 makes a quadratic equation parabola. The next example basically has a big old hairy polynomial taking away another big old hairy polynomial. The tricky part here is remembering that there's a minus sign in between, and there is still that little invisible 1 there. So again, it's going to get distributed to everybody. And in distributing to everybody, all the signs are actually going to change here. And I'm just going to bring down the first part here. Nothing's being distributed, so we're just going to bring it down. And I'm going to go through again left to right, finding any like terms. Again, I'm going to start with the largest power, and that's x to the power of 2. So 3 take away a 2 is 1, and you can put the 1 there, and it has a power of 2. I go through and find anything that has an x. My system here is actually to identify these by using different shapes around them. And there's my little 1, just so I don't forget about it. Negative 4 take away 1 is a negative 5x. And then I'll do some other little shape, moving on to the constant number. A positive 1 take away 7. Big number carries the sign. Gives us a negative 6. To simplify the next one, it's just like all fractions, to tell you the truth. All fractions have to be simplified. We just have to remember some key things, like the 2x in the denominator here is actually a common denominator for each one of the terms up above. So it can actually be written like 2x squared over the 2x minus 4x over the 2x. This is just one way to go and do it. Another way is actually to do some factoring. I'm not going to deal with that right now in this particular video because there's a whole section where we have to do some factor, cancel things. But I can just look at each fraction separately here to go and simplify. The 2's are going to cancel out. I have a x to the power of 1 down below, and that's going to cancel out one of the x's up top, which leaves us with x, a minus sign. The 2 goes into the 4, leaves us with a 2, and the x's cancel out. Binomial products is basically where we super distribute and then combine the like terms. You'll remember this as FOIL, a binomial times a binomial. I do use my little circles and my rainbows. It totally follows the FOIL. So we have to distribute the first term to everybody in the second binomial, which would give us x squared minus 2x. That does, as you do this here, you'll see this is the F, the first terms, the outside terms, so I am following FOIL. I like to use a different color for the next one. Make sure you circle the sign with it. This is what I call the reflection of the rainbow. And we have a positive 3x. I like to vertical add and subtract, so I just put my like terms underneath each other. Negative 6. If you're used to the other way of just going straight line horizontal, please do. And trying to keep to the doing everything from left to right, just like we read, we're going to add, combine any like term. A negative 2 plus a 3, big number carries a sign, so it's positive, and then you just kind of walk backwards from the big number. 3 take away the 2, gives that 1x, and minus a 6. The next problem is what we call a binomial square, and you have to be very careful here because the common mistake students make is to square the first term and then square the second term, but that's not what it's really saying. What it's really saying is power up the set of parentheses, which would give you an x plus 5 times an x plus 5. Totally a different result. Now, you can, of course, use the FOIL system, but from Algebra 1, it did lead us to a pattern of the first number being squared, the last number being squared, and these two right here happen twice. Positive 5x plus a positive 5x, so a positive 10x. All else fails, FOIL it, you'll get the same thing. The next binomials are my favorite the difference of two squares. And on this one, you square the first one, square the last one, and you put a minus sign in between. Two perfect squares and a difference. Let's try one that's just a little bit bigger. And again, I'm going to set it up with showing my distributing, what I'm distributing, where it's got to go. 2x times 4x, 2 times 4 is 8, number to number, letter to letter, x times x is x squared. 2x times a negative 1, 2 times a negative 1 is a negative 2, and the x. Next, we're going to distribute the positive 3. And the more often, just a hint here, that you include the sign in what you're doing with the operation, it will really help you take away some of those integer boo-boos, those little integer boo-boos that people have. So listen to me as I say this. A positive 3 times a positive 4 gives me that positive 12, and then the x. Positive 3 times a negative 1, give me those cute opposites, a negative appears. So a negative 3, and now I'm just going to combine my like terms. Get 8x squared, 12, take away the 2, or negative 2 plus a 12, the big number carries the sign, so positive 10x minus 3. We can also get these really large ones. I'm just going to erase some things so that it's out of my way. And this is what we call a binomial times a polynomial, but the distributing's the same. It's just super distributing and combining of like terms. And again, I'm going to use an identifier, circle what I'm distributing, where I've got to go. Be deliberate with your arrows. X times x squared gives me x to the third power. I'm going to leave a little space between the problem here. It doesn't hurt to leave space when you do problems and show work anyway, because sometimes if you want to go back and make a note, it really helps. X times a positive 6 gives me 6x, gives me 6x squared. Note how the powers are just going down here, and then x times a negative 2 is a negative 2x. Going to distribute the second part here. So I've got my little reflection rainbows. So positive 2 times x squared just gives us a positive 2x squared. Positive 2 times positive 6 is a positive 12x. Number to number, letter to letter, positive 2 times a negative 2 gives us a negative 4. And now I'm just going to combine our like terms, add them together for a result of x to the power 3, 6 plus 2, 8, x to the power 2. When we add and subtract, the powers don't change, just a coefficient. Negative 2 plus 12 is going to give me a positive 10x and a negative 4. Distribute, then combine like terms. Thanks so much. Have an awesome day.